All right, let's solve this exercise. So, given an m by n matrix, return all elements of the matrix in spiral order. And they show us an example of what this means. So, given this 3 by 3 matrix, we start at the top left, and then we go to the right, then down, then left, then up, then right. And same thing here. Okay, so basically I think it makes sense to, when you see a problem like this, I think the best thing to do is, well, just in general, if you're trying to solve a problem, it's best to start at a low level and then generalize. And typically you'll get to the solution through the generalization. So with something like this, it's good to walk through a few examples. And then that will generally help to show, no, this is not what I wanted to do. Why did this start? Okay. Okay, cool. So yeah, so let's work through some examples. So let's take this like 1, 2, 3. And really the numbers here don't really matter. But basically we're going in a spiral order. And so what we can think of is the first thing that we do is we return, like if we look at the output that we get, it's going to be it's going to be 1, 2, 3, 6, 9, 8, 7, 4, 5. Okay, so the first thing that we do is we get the top row going from left to right. So we get this row going this way. And then we go downwards along the right edge. So we get the 6 and the 9. And then we go right to left along the bottom, 8 to 7. Then we go bottom to top along the left, but here there's only one entry, so we just grab that. And then we go left to right across the top again, and we get this. And again, I'm including these arrows here to show which direction we're going, even though it doesn't really apply when there's just one element. You can still use that to help think of the process. But basically, at this point, we've maxed out the matrix, and so we're done. Okay, so basically, in looking at this example, let's go ahead and look at the next example and do the same thing. And I'll talk through, as we start to work through it, we can talk through how to think about actually writing out a solution. 9, 10, 11, 12. Okay, so the first thing that we do is we get the top row going left to right. And so basically, what we have here is we've sort of broken this matrix in half. The first thing, what is that? Okay. The first thing we've done is we've extracted, what is this thing? I have no idea. The first thing we do is we take off the top row and we just get all the values from left to right. But then what we're left with is we can think of like everything left over as a submatrix, which is where we're going to continue the process. So it's almost as if we go left to right across the top, and then that's gone. And then we go top to bottom along the right, and then that's done. Then we go right to left across the bottom. That gets rid of that. Then bottom to top along the left. That gets rid of this. And then left to right across the top, which gets rid of the remainder of the matrix. Okay, so how would we keep track of this? Well, let me write this out again. 5, 6, 7, 8, 9, 10, 11. 12. So as we're going through this process, we can think there's two things, or two like I don't want categories. I'll use that word. There's two categories of things that we're going to want to keep track of. We're going to want to keep track of like where we are at in the spiral, like which direction we're going, whether we're going up, down, left, right, and which edge of the matrix we're going along. So like the spiral pattern, we're going to want to keep that in mind. But we're also going to want to keep in mind which subset of the matrix we're working with, which submatrix we're working with. And so in thinking about that, so keeping track for the spiral, that will be, well here, let's go through this process again and think about the submatrices. And so how would we define a submatrix? Well, one way that we could define what submatrix we're looking at is by keeping track of the four corners of the submatrix. And so we could keep track of the indices of the top, let's see here, basically the top left, the top right, the bottom left, and the bottom right corners. Or alternatively, you could think of the top row, the bottom row, and the left column and the right column. So let's go with that. So we're going to go with top, bottom, left, and right. So at the very beginning, so let's go through this spiral process and see how this submatrix changes. So at the very beginning, we can think of what the indices associated with these are. Okay, so starting with the top. So the top row. If we think about how the matrix is specified here, we see that it's the matrix is a list of 3 elements, and each of those elements is a list of length 4. And so the entries in matrix are, like, each of the entries in matrix corresponds to a row. And within those rows, each entry corresponds with a column. Okay, so when we think of the top row, that's going to be, well, it's going to be at the very top of the matrix, and so that's going to be the very first row, which is row 0. What about the bottom? So the bottom is going to be the final row. And so if we count the number of rows here, we've got 3 rows, and so the index of the bottom row is going to be 2 because of off by 1 counting, because we're starting our indexing at 0. For the left and right, again, so for left, we start at 0 again. For right, we have 4 columns, and so it's going to be index 3. And so, by the way, we can already start to think about, okay, when we're starting our code, how are we going to initiate these values? Well, top and left are always going to be 0 and 0. For the bottom, what we did is we took the number of rows and subtracted 1. And the number of rows, we said, is the number of elements in the list matrix. And so we can take, like, the length of matrix and subtract 1, because the length of matrix is going to be the number of rows, and then we subtract 1 because of the counting starting at, indexing starting at 0. Similarly for the right, we have 4 columns, and how do we know that? Well, we can just look into any of the entries of matrix. So without loss of generality, we can just look into the first entry and see that the length of that list is 4. And so we take 4 and we subtract 1 because of the indexing at 0, and that gives us 3. So bottom, this will be the length of matrix minus 1, and right, this will be the length of the first entry of matrix minus 1. Okay, But we'll talk about that in more detail when we actually get to implementation. For now, let's just go through this process again. So we got, we're starting with the original matrix. Then we're going to pick off the, and I'm actually going to cross it out here. I think that might make it a little bit more straightforward. So we're going to pick out these four elements. And the way we're going to pick those out is pretty straightforward, because you take the top row and you can just extract all of the elements in that row going from left to right. So like you see here, the top row is going to be, well, we already have the index for the top row. It's 0. So we're going to pick out those 4 elements here. And we use the same order that they appear in because we're going from left to right. Okay. So then after we remove this, we're left with this submatrix, which is just the original matrix without the top row. So now, what would be top, bottom, left, and right? Well, left and right didn't change at all. So those are going to be the same. And also bottom is still the 3rd row. So it would still be index 2. So bottom, left, and right have not been changed at all. The only thing that's changed is the top row, because now we've removed the very top row. And so the top row of the remaining submatrix is row 1. Okay, so that's where we are here. And then the next thing we do is, from here, we're going from top to bottom along the right. So that's going to get rid of these 2. So how do we specify that here? So this is the rightmost column. We're going to get the elements from top to bottom. And so let's see here, how would we get that? So we know the index of the rightmost column because that's right here, it's 3. And going from top to bottom, well, we know the rows associated with that because we're going from index 1 to index 2. So we would just, for the ij entries of the matrix that we're extracting here, the j is always going to be the column index, which is always going to be 3. And then for the 2 I values, we're going to go with I equals 1 and I equals 2, because those are the indices between top, which is 1, and bottom, which is 2, just sequentially. Okay. And going increasing because we're going top to bottom. And top is less than or equal to bottom here. Okay, so that's how we're going to extract these values. And then the remaining submatrix after this, what has changed? So the left and the bottom are still the same as what we had at the very beginning. The top row in the submatrix, the submatrix I'm talking to now is this one. The top row is still 1. That hasn't changed. But the rightmost column has gone down from 3 to 2 because we just got rid of the right column. Okay. So then what we do is we go the bottom row, we go from right to left. And so that's going to get rid of these. And the way we'd specify that, again, we have the index of the bottom row, which is 2. And then we're going to go from right to left. So that's these 2 values. We're going to go from index 2 to index 0. But we're going to go in decreasing order because we're going from right to left. So we'll keep that in mind. And after we remove this, we're left with this submatrix. And so the top row is 1. The left and the right are unchanged, 0 and 2. And then the bottom row, we've just gotten rid of the bottom row, and so it's going to decrease to 1. Okay. And so then we're left with that submatrix. The next thing to go is this element 5. And again, we know given the top, bottom, left, and right, we can figure out the indices associated with this. It's just the leftmost and the top and the bottom are the same. But if we're thinking about the process we're going to go through, we'd basically be going from bottom to top in decreasing order. But because top is equal to bottom, it just gets the one entry. Okay, so there's that. And then after that, we've gotten rid of left, so the leftmost is going to increase to 1, but then all of the others have stayed the same. And then finally, what we do here is we get rid of the remaining submatrixes, this thing in the middle, and we're back to going from left to right, so we get rid of that. And so again, we know this is the top row, which is 1, and we're going from left to right, so index 1 to index 2. And then after we get rid of that, let's see here, so now, okay, so here's where it gets tricky. So if we think in terms of, oh, right, so if we think in terms of this process that we've been doing, first we increase the top row. For the indices, first we increase the top by 1 because we remove the top. Then we decrease right by 1 because we've gone along the right. Then we decrease bottom by 1 because we go along the bottom. Then we increase right by 1 because then we increase left by 1 because we've gone along the left. And so then we start over to increasing top by 1. So top is going to go up to 2, and everything else we're going to leave unchanged. Okay, so we are done with this matrix. But what here would indicate that we are done with the matrix? Well, in the original matrix, we had the indices for left, right, top, and bottom. And so we expect that the left is always going to be less than or equal to the right, and the top is always going to be less than or equal to the bottom. Notice that after we've removed this top row, top is now greater than bottom. And so everything we've done up to this point is valid, but it wouldn't make sense to go further because we no longer have a well-defined submatrix to continue working with, because the submatrix would have a top, the index of the top row would be strictly greater than the index of the bottom row, which doesn't make any sense at all. And so this is an indicator that we are done going through the matrix and done doing the spiral. And similarly, like I don't want to go through the process of like working through other examples, but you could also see that the other thing that could happen is instead of getting to a point where the top row exceeds the bottom row, we can get to a point where the left row exceeds the right row. And that would be invalid as well. Okay, so so this basically goes through the process that we're going to do. Is we're going to keep track of the top, bottom, the indices of the top row, bottom row, left column, and right column. We're going to extract the entries of the top row from left to right, and then increase the index of the top row. Then we're going to extract the values from top to bottom along the right, and then decrease the index of the right column, the index of the rightmost column. Then we're going to extract the values from right to left along the bottommost row, and then decrease the index of the bottommost row. Then we're going to go from bottom to top along the left side of the matrix, and then increase the index of the leftmost column by 1, and then start this process over again. And we're going to keep going until either the top, the top row exceeds the bottom row, or the left row exceeds the right row. And this is the process. So let's go through and actually code this up. All right, so like I said, we're going to have the index of the top row and the index of the leftmost column are always going to be 0. Now for the bottom row, remember the number of rows is the length of the matrix. And so the index of the bottom row is going to be this length minus 1, because remember, the length gives you the number of elements, and so to get the index of the final element, we need to subtract 1. Okay, and then for right, because we want to get the number of columns, we need to get the length of one of the entries of matrix. So we could just go with the very first entry of matrix. And we'll subtract 1, again, because we want the index of the final column. And so we need to subtract 1. Okay. And so then we're going to initiate our result as a list, and we're going to sequentially append values to it. Okay, so we're going to start this loop, and we're going to say while, hey, remember, the top cannot exceed the bottom and the left cannot exceed the right. So while top is less than or equal to bottom and left is less than or equal to right, what are we going to do? The first thing we're going to do is move from left to right across the top. Okay. And so I'm going to do this with a for loop. There might be neater ways to implement this, but I think this way is going to be like very clear and straightforward. So for I in range, so remember the elements that we're going to extract, we know they're going to come from the first row, and then we need to extract all of the columns. And the indices are the columns are going to be the indices going from left to right. So we're going to go from left to right. But remember, when we do range, when we work with range does not include that final element. And so we want to add 1 because we want to include the rightmost, because we want to include the index of the rightmost column. Okay, so then we go through this, and then we take our result, and we are going to append a particular value. And we know which row we're going to do because we're going along the top row. And then for the column, those are the values that we're iterating through. Okay, let me go through my notes just to make sure I haven't done any typos yet. Yeah, top, left. Okay. Okay. And so now what we've done is we've gone along the top, and so we no longer, so now we've removed the top row, so we can take the top row and increase it by 1. Now, what we said we wanted to do was we want to stop this process whenever the top row exceeds the bottom row or the left column exceeds the right column. And that's what we specified in this while loop. But with the way that while loops work in Python, it's not going to check this condition at every step of this process. It's only going to check once we return to the top of the while loop. So what we would want to happen is if right here, the index of the top row exceeds the index of the bottom row, we would want to stop immediately. But the code won't exit the loop immediately on its own. It will wait until it goes back to the top of the loop. And so we need to, we need to check this condition manually. So if top is now greater than bottom, then we're going to break, which means we're going to exit the loop. And then at the end of this loop, we're going to return the result. Okay. All right, so this is this looks a little inefficient because we're not, because this condition is being specified both in the loop itself and after every step that and like multiple times throughout the loop. So it seems a little inefficient, but this is sort of, I don't know that there are good ways to get around this. And in any case, the solution will work. So let's just move forward. So then we're going to move from top to bottom along the right. So across the top row along, I'm just going to say along the right. Okay. So for I in, maybe it might make sense to use like I and J. So like we will use indices I to refer to row indices and J to refer to column indices. Actually, yeah, let's just do this. Now here, the right column is fixed, but the index of the row is going to be changing, and it's going to go from top to bottom. So we're going to go, let's see here, so top. And so remember, top is going to be less than or equal to bottom while this loop is running, and so we're increasing. So top to bottom, and again, we need to add 1. Okay. And so just as a sanity check, if there's only one row, then the indices are going to be the same. And so this will be range from top to top plus 1, which will just return top, which is the index of the one row remaining. So this code will work if there's only a single row. And if there's 0 rows, that would only happen if top is greater than bottom, which is which breaks the condition that we're looping for, and so we would have already exited the loop by then. Okay, but basically what we're going to do here is we're going to result append matrix, and then the row, going to go the row, and then the column is going to be the index of the rightmost column. And then we're done with the rightmost column, so we're going to subtract 1. Because remember, the indices of the rightmost column, it starts at the length of matrix 0 minus 1, and then it's going to go down as we remove them. So yeah, so right minus equals 1. And then we again need to verify if left is now greater than right, then we need to exit. Okay. So now we've got 2 more. Now we're moving from right to left across the bottom. Across along, I don't know. I think for going from top to bottom, I think along definitely works better. For going from left to right, I think along or across would work. So let's just do along to be consistent. But okay, that's enough like English semantics. So now we're iterating across the columns, and we're moving from right to left. So we're going to start at the rightmost column, and then we're going to end at the leftmost column. And we're going to be decreasing because because right is going to be strictly greater than left. No, right is going to be greater than or equal to left, so we're going to be decreasing. And then also that means that we want to end at left. So we need to like overshoot by 1 so that we get that final index. And so we need to subtract 1 rather than adding 1 because we're moving, because we're decreasing. Okay. And then result.append matrix, and then the row is going to be, let's see here, the bottom. It's the bottom row, so we're going to go bottom, and then the column is going to be column. All right, and then the bottom row, we're going to subtract 1. And then again, if top is greater than bottom now, we break and move from bottom to top along the left. then for row in range, so we're going from bottom to top. We're going from bottom, top, and again, we're going from a larger number to a smaller or equal number, so we're decreasing. And so we also need to subtract 1 here. And we're going to append the index of whatever row we're on, and then it's the leftmost column. And then we're going to take the leftmost column and we're going to add 1, and if left has become greater than right. Oh, well, actually here, this is the final one, so we don't actually need to include it, because at this point we're going to go back to the top of the while loop, and so here it will actually check it here. And so we don't need this extra break statement here. Okay, and then this loop will keep going until one of these two conditions breaks, at which point we will return whatever we've gotten. So let's submit this. No. Yeah, there we go. So yeah, that's pretty much how you do this problem. And again, I think this sort of speaks to the value of like not jumping into the programming, but really first working through some examples and trying to understand the problem, and then using that, doing that until you have a solid understanding of how the process is supposed to work, and then generalize to write the code that will work in general scenarios. But yeah, that's how you do this problem.